So I just wanted to review the power laws, laws for dealing with, or rules for dealing with powers when you combine them. So this is a copy of our graphic organizer here. You'll recognize the section here that relates to the laws, and you can download a PDF version of this graphic organizer from the website. So I'm just going to zoom in a little bit here so we can see this more clearly. If we're multiplying or dividing powers, then we can simplify them using these rules. So here's a rule for multiplying. So when you multiply two powers, this is a power here, and this is another power, and they have the same base. You can see they both have a base of a, but their exponents are different. And to simplify this, we add together the exponents. If we're dividing, either using a division sign here or by using a fraction, then what we do is we subtract the exponents, as long as the bases are the same. And these rules are called the product rule and the quotient rule. We can do a couple of other things. If the bases are different, as in this case they are different bases, but the exponents are the same, then we can multiply the bases. And a similar example with roots. If the roots are the same kind of root, both square roots as in this case, but the bases are different, then we can multiply those together. We don't do very much with this, but we do use this rule a lot here. So let's scroll across to some examples, to look at some examples. So if we want to see how these rules work, we can always write them out in full. So here we could simply write out what's in the brackets over here. So 2x squared is the same as 2 times x, and 3x is obviously 3 times x. If we multiply the 2 and the 3 together, we get 6, and we see we've got 3 x's multiplied together here, which makes x cubed. And that's the same answer as if we just add together the exponents on the x's. If we're dividing, then we subtract the exponents and we divide the numbers. Again, if I write it out in full, I can see how it would look. 3 times x times y times y times y times y divided by x times y. And we'll see that some of these x's and y's cancel, and we're left with 3y cubed. There's no x in the answer, because when we subtract the exponents from the x, we get x to the exponent 0, and anything to the exponent 0 is 1. Couple of things to watch out for. We are multiplying, so even though we're adding the exponents, we're actually multiplying. The adding the exponents is just kind of a shortcut way of combining them by multiplying. So in this example here, we're multiplying the x's together, and the way we do that is by adding the exponents. We're also multiplying the numbers together. These numbers here are called coefficients, the numbers in front of the variable parts. And we have to multiply those together as well. So negative 2 multiplied by 4, which is negative 8, and then that multiplied by 3 is negative 24. So we just have to be careful with that. Let's take a quick look at the power of a power rule, which was the last of these power rules. And this one looks like this. If you have a power, you can see here we've got a power, has a base and an exponent. And then here outside the brackets we've got another exponent. It doesn't have a base, so we're not multiplying two powers together here. We've got a power of a power. And as Hannah in our class mentioned, this is kind of like thinking of it as an overall power that applies to everything inside these brackets. So if we have a power of a power, then what we do is we multiply the exponents together. We don't add them. If you're ever unsure about what to do, best thing to do is to write it out in full like this. So here we have 2x squared cubed. So 2x squared looks like this, 2 times x, and this cube means we have 3 of these brackets all multiplied together. And when we simplify this, 2 times 2 times 2 is 8, and we've got 6 x's here, so 8x to the power 6, or 2 cubed times x to the power 6. Either way is fine. Again, I've got some examples here for us to look at. In this example, we can do the here now we're multiplying. This is just the product rule here. So we've got two separate powers, an x cubed and an x squared. So if we're multiplying these together, we would add the exponents. So we get x to the 5, and I've got it written out in full here so you can see that that is in fact the case. Here though, we have a power of a power. It's not two separate powers multiplied together. So I would multiply the exponents here, and I get 6 for my exponent, and this explains how that works. This is a really tough problem here. You definitely wouldn't get anything any more difficult than this. Here we have, we've got a power multiplied by another power here, and then divided by a power, but we've also got this 3 here, which is a power of a power, and this 4, which is a power of a power. So I want to simplify first by doing this exponent here that's outside the brackets. So what we would do is it applies to everything in the brackets. So negative 2 cubed is negative 8, and then we multiply the exponents here to get x to the 6y cubed, and then on the bottom 6 to the exponent 4 actually turns out to be 1296, and then multiply the exponents together here. If I simplify that, the top and bottom will divide by 8, and then I can subtract the exponents since I'm dividing here, and I get negative x to the 5 over 162y. So that's a really complicated one. Certainly wouldn't need to do anything more complex than that. Okay, so that's the power rules, and that's it with powers. So the graphic organizer now you can complete, and if you need a little bit more practice with the power rules, then you can do that by trying the problems indicated on this page.